So another example of differential of equation 1 with exact equation. So test for exactness and solve the equation of the quantity of 6x plus y squared dx plus y times 2x minus 3y dy equals to 0. So again, the equation is only exact if the partial derivative of m with respect to y is equal to partial derivative of n with respect to x. So first, test for exactness. So our function of m, we have 6x plus y squared. So the partial derivative of m with respect to y, holding x as constant. So derivative of partial derivative of 2y, y squared is equals to 2y. Then for our n function, we have y times the quantity of 2x minus 3y. So for the partial of derivative of n with respect to x, holding y as constant. So the derivative of 3y squared is 0. So what is left is 2xy. So derivative of 2y times x. So we have 2y times the partial derivative of x, which is 1. So 2y times 1 is 2y. So therefore, partial derivative of n with respect to y is equal to partial derivative of n with respect to x. Therefore, our equation is exact. So for our solution, first, then we let m equals to partial derivative of f with respect to x, which is equal to 6x plus y squared. And denote this as equation 1. Then second, our n function, which is equal to partial derivative of f with respect to y, which is equal to 2xy minus 3y squared, and denote this as equation 2. Then integrate equation 1. So we have integral of partial derivative of f equals to the integral of the quantity of 6x plus y squared times partial derivative of x. So for our integral of 6x partial derivative of x, so it is partial derivative of x, so equals to 6 times x squared over 2, or we have 3x squared plus c. And then for our y squared integral of partial derivative of x, then we have xy squared plus c. So the result is f equals to 3x squared plus xy squared plus hy, and we denote this as equation 3. Then next, we differentiate equation 3 with respect to y. So the derivative of 3x squared is 0 since x is constant. So what is left is xy squared, where x is constant. So the result is we have the derivative of x squared equals to x times 2y plus y squared times 0. Or simply we have the derivative of xy squared is equal to 2xy. Then the result is partial derivative of f with respect to y equals to 2xy plus h prime y. And we denote this as equation 4. Then equate equation 2 and equation 4. So from our equation 4 and equation 2, we have 2xy plus h prime y equals to 2xy minus 3y squared. So 2xy will be cancelled out. What is left is h prime y equals to negative 3y squared. And we let this as equation 5. The next, integrate equation 5. So we have now the integral of h prime y dy equals to the integral of negative 3y squared dy. So integral of h prime y dy is hy. Then the integral of negative 3y squared is negative 3y cubed over 3. So 3 will be cancelled out. That's why we have h prime, hy equals to negative y cubed. And we let this as equation 6. Then we substitute equation 6 to equation 3. So we have f equals to c equals to 3x squared plus xy squared minus y cubed. Or simply we have c equals to 3x squared plus xy squared minus y cubed.